Good morning and Varana. This is Bhaskar Dhananjay Kumar with my teammates Lokesh Babu and Kiran Kumar Reddy. I'm here to present my project which has a title of Image Fusion on MRI and CT images using deep learning. These are major project and these are the agenda of our project starting from abstract and ending to conference obligation proof. And coming to our abstract, in this project or in this proposed model, we try to fuse different medical images will increase the accuracy in diagnosis of disease and describe the complicated relationship between them for medical research. In this model, we'll retrieve the complicated information from different images like magnetic resonance imaging and computed tomography by using them through multi-stage fusion networks. In the proposed model, we will use in this proposed model, we'll use jewelry complex wavelet transformation to extract the complicated and correlated information from each images, and segmentation is done on fused image to get the segmented image. In the proposed model, the fusion of multimodal medical images can be done by jewelry complex wavelet transform, where the source medical image is converted to grayscale and decomposed. Then the wavelet coefficients are extracted using DTCWT. After that, approximation of wavelets are done to obtain the fusor coefficients, and these are the aim and scope of our project. The aim of our project, named image fusion using MR and KT images using deep learning, is to develop a novel method that leverages deep learning techniques to fuse MR and CT images by combining the complementary information from both imaging modalities. And the project aims to enhance the accuracy and quality of medical images analysis and diagnosis. Scope of the project is to multimodality images plays an important role in medical imaging field as the extension of clinical use of various medical imaging systems. Different medical imaging techniques may provide scans with complementary and occasionally different information. This is the introduction which starts from X-ray, polytron, MRI, PET, single photon emission, computed tomography, and magnetic resonance imaging, MRI, CT in medical images. These medical images systems will provide different medical information regarding tissues which are complemented in most cases. For example, X-ray is used for identify bone injuries and bone fractures. CT images will use elaborated information of internal organs, tumors, and blood vessels. MRI is used to provide the information about the tissues. And coming to the next slide, all the features gathered from a single images in order to extract all the complemented information from a single. We are using the medical images of single different system. The medical image fusion is defined as the process of matching different kinds of medical images. These are the introduction literature use. Through these papers, we have studied what the MRI images and CT scan images are useful and how, where we are using this for the identification of problems. And these are all the literature papers. And coming to our modules, we divided our project and proposed model into three modules. Module one comes under image decomposition method, in which we decompose our images which were collected as the raw data sets of three type like 3D MRI images with each to 512 to 512 pictures in size. And coming to module 2, extracting features using DTCWT. After decomposition, we will extract the intensity based on such as -15 to +15 if the data is greater than size. Principal component analysis may be utilized to extract the quiet and complementary characteristics. PCA is utilized to minimize the data in this case because the medical photos are greater. Coming to module to second part, as a result, we calculate the covariant matrix to discover the correlation in order to identify the primary component. It is also necessary to compute the eigenvectors and eigenvalues of the covariance component. In these frequently employed in remote sensing, medical imaging, and computer vision. And coming to module 3, image segmentation, a procedure known as image involves breaking a picture into a number of regions or segments. Image segmentation methods can be done using thresholding, clustering, region-based approaches, or deep learning-based methods. Coming to stand, these are the standards and policies which we have for implementation comes under architecture diagram, use case, class, sequence, activity, and these are the diagrams. And Coming to testing part, we have done three types of testing: unit testing, integration, and system testing. These are the test cases which taken from the dataset MRI and CT images, producing a few images that requires important information from both modalities. Testing the robustness, testing the efficiency of deep learning in unit testing, and coming to integration, the robustness of deep learning model by introducing various input data such as image noise, antifrats, or variations in imaging parameters. Testing the scalability of the system by increasing the size of the dataset, and coming to system testing, testing the robustness of the system by introducing noise or artifacts in the input images and ensuring that the fusion process can still generate accurate, reliable fusion images. This is our input and this is our output screenshot of fusion image of MR and CT. Coming to conclusion, medical images are used for diagnosis. This is unhelpful for the treatment through MR and CT images, magnetic resonance, and by using DTCWT for process, further extraction of coefficients and approximation of extracted coefficients are performed, and the inverse geometry complex Euler transform is applied to the fusion image. Finally, segmentation is performed to obtain the segmented image. And the future enhancement, there are several potential enhancements such as integration of additional modalities, advancement deep learning architectures, incorporation of clinical data. So YouTube link of this video, and coming to these references, plagiarism report of our final report. So our poster made and coming. Thank you.